Okay, here we have sets of numbers as subsets. Beginning with the natural numbers, we have expanded each set to form a larger set, meaning that there is a subset relationship between the sets of numbers we have encountered so far. The relationships become more obvious when seen as a diagram, such as what we see in Figure 3. Now, capital N here represents the set of natural numbers. So recall that this represents the natural numbers 1, 2, 3, and so on, which are the counting numbers. Then we use W as the set of whole numbers. So if you look here, that means it's including the 0. Then we have the set of integers, which includes the negative numbers. Then we have the set of rational numbers, which are all the numbers that can be written as a fraction that are either a terminating or a repeating decimal. And then the last one we have is a set of irrational numbers. And recall that the set of irrational numbers are the numbers that are obviously not rational, but they're not terminating and they're not repeating. So for example, is pi, square root of 2, etc. So here's a set of natural numbers. Set of numbers includes numbers used for counting. The whole numbers is a set of natural numbers plus 0. The integers adds the negative natural numbers in the set of whole numbers. The set of rational numbers includes fractions. And we have irrational numbers. Now, in example 5, we're differentiating the sets of numbers. So we're going to classify each number as being a natural number, n, a whole number, w, an integer, I, a rational number, q, and or an irrational number, q, with an apostrophe. So we're going to first take a look at the square root of 36. Now the square root of 36 can be simplified as 6 because a number that squares to get 36 is 6. Well, 6 is a natural number. It's also in the set of whole numbers. It's also an integer. And it's also a rational number because it can be written as a fraction. But it's not an irrational number. Let's take a look at 8/3. Now 8/3, okay, is a fraction that can be written as a decimal. Now this decimal is a repeating decimal. So it's a fraction that's written as a repeating decimal, so then we know that it's an irrational number. But it's not a natural number because it's not in the set of natural numbers. It's not a counting number. It's not a whole number because it's not in the set of whole numbers. It's not an integer because it's not in the set of integers. And it's not an irrational number. So the only one that we can mark that as is an rational number. Let's take a look at the square root of 73. Now, let's take a look at the square root of 73. Okay, if we plug that into our calculator, okay, we do not have a number that we can square to get 73, and we get that number 8.544003745. So it doesn't terminate, and it's not repeating. Therefore, the only option that we have is that it's an irrational number. If we take a look at the next number, -6. Well, it's not a natural number because the natural numbers are the counting numbers that start at 1. It doesn't contain negative numbers. It's not a whole number because it contains 0 in the natural numbers. But it is an integer because the integers can contain negative numbers. And it's also a rational number because this number can be written as a fraction. Last one, we have 3.212112112. Well, we can see that it's not a natural number because it's not a counting number. It's not a whole number. It's not an integer. And then we have to differentiate between it, whether it's a rational and irrational number. Now, a rational number means that it's terminating. This doesn't have a terminating decimal. A rational number also means that it's a repeating decimal. It's not a repeating decimal. So this is an irrational number.